Good morning, 6-7. I hope you had a wonderful weekend and are ready to start yet another week of school. We are getting down to the end of our data and statistics unit. We're going to have lessons this week, and then next week will be basically a review, and you'll have your assessment about middle of next week. For that assessment, I'll give you more information then, but it will be a sort of a project type thing rather than a standard assessment, Google Forms assessment. So let's get going with what we're doing today. Today, we're going to be working on stem and leaf plots. Now, you might be asking, what is that? And we're going to explore that in just a second. Your learning targets today are to create a stem and leaf plot to help you visually organize your data. Okay, it's always important that rather than just having this big jumbled mess of a bunch of numbers that you can't make sense of, you want to keep it organized so that you can go through and you can figure out, okay, what is this telling me? How can I make sense of it? How can I analyze it? Okay, and as always, to help yourself as a student, make sure that you're giving 100% effort because that will always help you to understand everything better. Okay, so let's get back to that question of what is a stem and leaf plot? Okay, well, the stem and leaf plot simply is a way of visually organizing sets of data. Okay, let's pretend that I had asked, that I wanted to find out more about the amount of time I spend on the phone. And so I looked at 13 of my phone calls, and I looked at how long they were, and I made a list of how long those 13 phone calls were that gave me this data set sort of in purple. Well, right now it's just a jumble of numbers, and I can't really make a whole lot of sense of it. I don't know if I spend a lot of time on the phone or just a little time on the phone. I really don't know where it is. So I need to organize this data quickly so that it makes the most sense. So what I'm going to do is I'm going to create a stem and leaf plot. And stem and leaf plots look a little like this. They look like T-charts. Okay. Stems, that left side, are the tens place value of your numbers. Okay. When you get into hundreds or even higher numbers than that, your stem changes a little bit. But for this example, your stem is your tens place value. Your leaves then are going to be your ones place value in all of those numbers. So you're essentially breaking those numbers into the tens place and the ones place and then organizing them. One of the most important things to remember about organizing them is you have to put both your stems and your leaves in order from least to greatest. Okay, so to help me do that, I'm going to go through, and as I get to them, I'm going to cross through what numbers I've already used. Okay, so I am going to start. My very first number here is a 2. Well, if I think about what the tens place value is in a 2, that number is going to be a 0. Okay, and that's okay if your stem is just 0. There are 0 tens. Okay, so now I'm looking just for the single digit numbers. Okay, well, I have 1, 2 right there, 1, 2 right there, 1, 2 right there, and no other single digit numbers. So what I'm going to do is I'm actually going to write 3 2s because I have 3 separate 2s in my data list. Every single one of these leaves represents one number, one answer from my data set. Okay, so we've taken care of the zeros. Now we're going to do those that have a 1 in the tens column. Well, I have a bunch of them. I have a 15, I have 13, 17, and 16. Okay, again, it's always important to put those in order from least to greatest. So I'm going to start with my smallest, which is 13, and then 15, and then 16, and then 17. Okay, you'll notice on those leaves, again, all I'm doing is writing that one's value. Okay, next, I have the 2s, or there's numbers that are in the 20s. So I'm looking for numbers in the 20s. There's 1, there's 1, there's 1. Okay, so my first number is 20. 2 in the tens, 0 in the ones. So there's 20. Then I have 21. Then I have 23. Okay. Next, I'm going to go through and I'm going to do the threes. Now the threes, I have 32 and I have 37. So I'm going to put 32 and 37, cross those out, just so I have that visual reminder that, yes, I've included them in my list. And my last number, which I'm running out of room for, is going to be 47. Okay, so 47 is going to be that stem of that leaf. Okay, you'll notice a couple of things about this. Okay, one, I don't put any commas between the numbers of my leaves. I don't need to. Every single digit that's there is representing a separate value that's in my data set. So I can just put those numbers one right after each other. And I know when I'm reading this and interpreting this, that means that each one of those digits is a different piece of data from my data set. Okay, let's look at another data set. Okay, let's say this time I looked at the number of letters in my first and last name of various students, and I created this list of data. Again, right now it doesn't make a whole lot of sense, but I would put it in order in my stem and leaf plot. Okay, I've already done that for you. I have organized those, and I can figure out just by counting them up how many pieces of data are in that situation. So I can just count the leaves. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I know just by looking at it that there are 15 pieces of data in that original data set. So I wouldn't even have to have these numbers up here. All I would need to know is my stem and my leaf plot, because it tells me how many pieces of data I have. I can also look at it and I can say, no, what is my largest number versus my smallest number, just by looking at how this is organized. My smallest number is going to be the one that has the smallest tens value and the smallest ones value. So in this case, it's just going to be the number 8 is my smallest number. Okay, for my largest, I'm looking for the largest tens value and the largest ones value. So in this case, my largest number is going to be the number 26. These stem and leaf plots are great for helping you figure that out really, really quickly and really, really efficiently. The other thing they help you with is something called variability and consistency. Now, we looked at variability when we first started talking about statistical questions. And what variability meant is having a wide variety of responses. Okay, we can look at the stem and leaf plot and decide, do we have a wide variety of responses? Are they sort of all over the place? Or do we have a consistency within our responses? Well, if you look, the majority of our responses are somewhere in the tens. Okay, we have 1 in the single digits, we have 3 in the 20s, but the vast majority of our answers are going to be in the tens, the teens, things like that. And so because of that, this question, at least the data we received from it, does not have a lot of variability. Okay, we don't have answers that go from 0 all the way up to 100 as part of this, looking at this. We only have a very tight and compact set of data that all seems to center around that 1 as the stem. These stem and leaf plots are a great way for you to recognize whether you have variability, so you have lots and lots and lots of different answers, or whether you have consistency, meaning most of your answers are all right around the same number. Now, if this had a lot of variability, I wouldn't only have 3 stems. I would probably have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, even up to 10 as my stem. That would show I have a wide variability because there are a lot of different answers. Okay, but the fact that this one only has 3 stems and the majority of my data is only around 1 of those stems tells you that I have consistency with my data. Okay. As always, if you have questions about this as you're going through the activities or as you are working with any of the things that you have to do for stem and leaf plots, make sure you send me a question either through email or through chat, or come to our live chats.